The following is from Summer 2009 Math 263 Past 2, number 8. Find the maximum volume of a rectangular box with 3 faces on the coordinate planes and a vertex on the first octant. Now first define the function you are about to maximize in terms of x and y only. This question actually to be done using the regular method, but here I will show you how to do it by Lagrange method first. Okay, first let's draw what's the situation. It is in the first octant. That box looks like this. Okay, now the vertex they are talking about is this one, this vertex. Let's call that XYZ. Now this point here, a vertex has to be on that point, so this point here should satisfy 3x plus 2y plus z equals to 6. Now I hope you can see right away that x and y and z are all non-negative. Okay, now because it is in the first octant, that's first. Second, why not Thomas that either one of them or two or three, all three of them equals to 0? Well, if they are equal to 0, any one of them equals to 0, you can tell that the volume will be 0. Okay, now so that's our restriction. I hope that makes the question a lot easier. Now then the volume we want to maximize equals to XYZ. That's the maximize. And the constraint is the that 3x plus 2y plus z equals to 6. That's the constraint. Now, using Lagrange multiplier, del v equals to lambda, or let me call this the constraint, what do you like, g. Okay, del g. Okay, of course at the same time the g xyz should be equals to 6. Okay, now let's put them in detail. The gradient of v will be yz and then xz and then xy equals to the lambda of 3, 2, 1, and at the same time 3x plus 2y plus z equals to 6. Now let's put them together. Yz equals to 3 lambda, xz equals to 2 lambda, and then xy equals to lambda, and then 3x plus 2y plus z equals to 6. Now of course there are many ways to do this. But I guess a couple things we can do is the following. Let's multiply something. Notice that this one here, I will the lambda is equals to xy, so let me do it this way. So yz equals to 3 lambda, which is equals to xy, right? So basically yz equals to xy, I mean 3xy. And because we know that the y, x, y, z are actually positive, then I can divide by y here and I get z equals to 3x. Is okay? Now likewise for the second equation, xz equals to 2 lambda, which means 2xy. You will see then xz equals to 2xy. I can cancel the x, I get z equals to 2y. Okay, now using this I will put this into the constraint. Okay, 3x equals to z, 2y also equals to z, 3z therefore equals to 6, z equals to 2. Now once we find that z equals to 2, that implies the x equals to 2/3 and the y equals to 1. Okay, now that's the coordinate that we need. Let's see the volume, therefore the phi equals to xyz, which is equals to 2/3 times 1 times 2, that's 4/3. That's the volume. And the dimension, they don't ask us the dimension, but we can tell the dimension is given by 2/3, 1, 2. Okay, that's the maximum volume using this Lagrange multiplier method.